Because of COVID-19, there has been an explosion in PPE usage. With the explosion came an inevitable shortage of resources across the country. Read this. The U.S. Department of Health and Human Services estimated in early March that the U.S. had 1% of the 3.5 billion N95 masks needed to manage a full-blown COVID-19 pandemic. We need to figure out a way to safely and efficiently reuse PPE to conserve these precious protections. Introducing Sterile Laser. We combined hardware and software to create a user-friendly sterilization system utilizing the power of UVC lamps. For software, we used Flutter for the front end and Firebase and MongoDB for the back end. For hardware, we have two UVC lamps which are controlled by a Wi-Fi smart plug that listens to all incoming requests and commands from an endpoint. The smart plug is daisy linked to the two lamps so they work on one connection. The configuration and status of the disinfection chamber is stored in a MongoDB database. The server and control mechanism for the chamber were written in Python. The commands the user creates are stored in Firebase.
Alright, I've placed my PPE right here, and then I am going to turn our system on using my API endpoint. So right now you can see currently it's off. Refresh that, it's off. Turn this guy on. So this is the on endpoint. Okay, let's go back here, refresh. Should be on right now. Let's take a look. As you can see, the PPE here, it's on, and we are in the process of sterilization, and we're gonna go quickly and turn it off. Let's go here, refresh, this is on. Let's go to the endpoint that turns it off, and then let's hit the endpoint real quick. It's off. Let's go back here, refresh, should be off. Let's go and find out, and there it is.
Now you may be asking, why UV? We chose UV for 4 primary reasons. UVC disinfection is environmentally friendly, fast, cost efficient, and very easy to use. There are no dangerous or toxic chemicals required for handling. There are no byproducts made from the process, as well as the bulbs do not require handling or disposal, which makes the system a great alternative to chemical disinfectants, which produce a lot of waste. UV also works very fast. A typical room takes about 15 minutes to disinfect with UV, taken from Chlorodice's UV Light disinfection datasheet. The cost to run UV systems is super low. Our product can be run by a wall outlet, which provides great accessibility as well. A typical UVC treatment costs under 2 cents. A UV bulb can last thousands of hours, which eliminates the need for regular maintenance. The simplistic nature of UV disinfection systems provide a great user experience, and paired with an app makes the system even more straightforward. Right from the start, the user can input a time and turn on the hardware with a click of a button and start disinfection. When the time comes up, the user is then prompted that the sterilization has finished, and the lamp turns off to conserve energy. The user can program the machine itself by creating commands that they can click to use the chamber for a specified duration. To create a command, you click the button at the bottom, fill in the information, and it will be saved to your profile after recording the data in the Firebase backend. When you start the timer, the app will make a post request to an endpoint, which is listened to by the Wi-Fi smart plug, and thus the sterilization begins. Here's our implementation model. First, we will polish the prototype, better UVC lamps, a better chamber, and integrating the Wi-Fi plug. We would then need to get whatever safety approval we need, then acquire funding to promote and mass produce our product, assuming we surveyed surrounding hospitals and got a resounding need for Sterile Laser. We would also take user feedback to analyze trends and examine closely how people are using Sterile Laser, so we can improve our product in those specific areas. For our organization, we would need to create a marketing team that takes care of all the publicizing and communication. Our product development team would approach experts on how to build a concise and clean product to distribute to our target audience. Our research team would delve into how Sterile Laser can improve its disinfection efficiency and also analyze user trends to relay that information to the PDT so they can upgrade the product to meet demands. Finally, a management team would take care of all finances, work distribution, and liabilities so we can grow our business ethically. Thank you for watching, and I hope you see the potential Sterile Laser has for changing the world of PPE conservation.